So the first thing we're going to talk about today is feature detection and machining. Now this is a brand new feature that's been added to version 2017. It's available in our mill module and the Visual Cam 2017, Rhino Cam, and also will be available in Visual Cam for SolidWorks as well. Now the feature-based machining, this method, the feature detection, can detect prismatic features and also 3D pocket features. We'll go over an example on how to detect features and how to program toolpaths from features that have been detected. Now the part what I have here is a solid geometry, so you could be working with a solid or a mesh geometry, solid surface mesh geometries. So to detect features from your Visual Cam menu, you select the mill module. Once you have the mill module visible, you have your machining browser, and then you click on Tools Machining Objects, and you'll find the Machining Objects browser, which typically appears over either below the machining browser or over on the side. And you click on the Features tab, which is right by your Tools regions. Click on Features. Now as you select the Features tab in here, you'll see that there's a Create Machining Feature option. Selecting the Create Machining Feature will prompt you to select a face. I'm going to pick the top face of this part and then press Enter or right click. And this will automatically detect the features from the part. So I'm going to take this browser and move it over to the side here so all of you can easily see the features that are being detected in here. So you will notice that there is 3 different types of features identified on this part. We have planar faces, and the feature is highlighted on the part. We now have prismatic pockets. You can see that all of these pockets features have been identified on the part as well. And we have a hole feature that's been identified as well. Now once you have these features detected, you could program toolpaths directly from these. So first I would like to program a toolpath for the planar face. So right click on it, it gives you the available operation types. I'm going to pick facing, and the feature is automatically selected. Make a selection for your tool. You can specify your cutting parameters, generate. And there's your facing toolpath for the planar face. We'll now program the prismatic pockets. Select the prismatic pocket feature. Right click on it. You can select facing, pocketing, or profiling. In this case I want to do a pocket machining. I'm going to choose pocket. Specify a tool for it, generate. You'll now notice that the toolpath for the pocket, for all of those pocket features that have been identified, have been generated. Now finally on this part I have this hole feature. I would like to program it as well. Select the hole feature, right mouse button click, and I can choose from all of these available operation types, and I'm going to program hole pocketing. Select a tool, and I'm going to hit generate. So there's the toolpaths for each of those 3 features we've identified in here. Now let's go ahead and run a verification. So I'm going to go to the Simulate tab, pick the operation, and then hit play. And there's the verification. So the steps: we identified the features, and then we programmed toolpaths for those features we identified. So in just a few button clicks, you could generate toolpaths for each of these features that you identified. Now I would like to also show you how we can identify other types of features. Now for this I'm going to go into our Rhino Cam product, and you'll see that on this particular part I have some slots and holes on it. So we'll repeat the same process. We'll go into the Features tab under the Machining Objects browser. I'm going to click on Create Machining Features, pick the face, right click or press Enter, and you'll notice that the features have been detected. So I'm going to move this over to the side so you can see all of the features being detected. We have a planar face, we have slots, prismatic slots. You'll notice that there are 2 types of slots 2 slots in here, and all of the slots have been identified, and as you select each of these slots in the tree, it highlights the corresponding feature on the model as well that's been identified. And then you have the set of holes, the hole features. Now you could program all of these slots in one operation, or you can split them into 2, where I can select all the top 4 slots. I can hold my shift key to multiple select, and I can right mouse button click and choose slotting. Now you'll notice that those slot features have been added. You can make a selection for your tools. I'm going to use a 1/2 inch end mill, establish the slot parameters, and generate it. So in this particular case, you can see that the toolpath creates a tricorder toolpath when the tool diameter is smaller than the width of the slot. So if you have a tool that's exactly the same width as the slot, the toolpath would be different, and which I'm going to show it to you in just a moment. So I'm going to select the second set of slot features in here, right click on it, pick slotting, and I'm still going to use the same 1/2 inch cutter, and then pick generate. So you'll notice that the width of the slot here is 1/2 inch, and the tool I'm using is also 1/2 inch, so it automatically identifies the center line to create a single pass for the slotting toolpath when the width of the cutter is same as the slot width, or the diameter of the cutter is same as the slot width. Now in the case where the diameter is smaller, this would result in a tricorder toolpath. Now we can also identify other types of slots, which I'll give you an overview of what other slot types we would be able to identify. Now these are prismatic slots. Typically on prismatic parts you would be able to identify different types of prismatic features. We can also identify pocket features on 3D geometries, and for that I'm going to go ahead and take a look at another part in here. So what I have here is a solid geometry with a cavity, a mold cavity in here, and you can see it has sculpted surfaces on it. I'm now going to go over to the Features tab, click on Create Machining Features. I'll pick the face on the part, and then right mouse button click. So this will identify the features on this part. We have a planar face for the top, and we have a pocket feature. This is a 3D pocket feature that's been identified from this mold cavity. Now once you have the features identified, you can program your toolpaths. Right click on it. I can start with the roughing process, specify a tool. I'm going to hit generate. I'm also going to go back and add a finishing pass on it. Pick a parallel finishing toolpath, select a tool, generate. So you could detect features from solid surface mesh geometries. You need to make sure that if you're working with surfaces, you stitch them or you join them to a closed geometry, or you can even work with polygon meshes like STL files, identify features, and generate toolpaths. Now you got to remember that in this feature detection, if you have multiple step pockets, there are certain limitations on what type of features we can identify, and here's a summary of the different features we could identify. We could identify holes, closed pockets, open pockets, non-prismatic pockets, like the 3D pockets you looked at in the previous example. We could identify bosses, through slots, through T-slots, prismatic slots, both open and closed slots, and planar faces. So the 2017's MIL module feature-based detection and machining allows you to identify these different feature types. Now these are available in starting with right from the standard configuration. So if you have standard, expert, pro, and premium, all of these configurations of our MIL module includes the feature-based machining.